Hey, so I'm going to be doing a summary on machine learning with R in a slightly different format than a written summary because I believe there's pretty good written summaries available and the textbook is pretty comprehensive. So I think what would be a good auxiliary support to that is an actual standalone alone or in combination with the textbook is to see a video tutorial of the actual code being implemented. In this way, people can fast forward, rewind, or slow down the video as necessary for the particular instances they're having trouble and possibly gain insights that are not explicitly said in the textbook by the person conducting it. So I'm going to be skipping chapter 1, which is an introduction to machine learning, but I believe that everyone should read this chapter because it gives you a good background on what you can expect out of machine learning models and algorithms in terms of how to get your data, clean it, how that process works, what different types of machine learning models can do in terms of their predicting capacity, and what you can expect to predict, whether it's the chance that a cancer tumor is benign or malignant, or if an email contains spam or not. Um, Many of these things will actually be addressed within these actual video tutorials, but I think a good background is actually within the first chapter. I'll be starting off with the second chapter that's managing and understanding data, which is a background on R. Alright, so this is our studio, which we're going to use to actually be explaining some of the R code that's used in the textbook. So chapter 2, which is managing and understanding um, data. What we have to do first is understand the different types of data structures that are used in R. The first of which is a vector. Now, a vector is an ordered set of elements of the same type. So the types of these elements can be things like integers, which are numbers like 1, 2, 3. Numerics, which are bigger numbers, so something like 10,048. You can have characters, which are strings, so like my name, Rayner. You can also have logicals. So logicals are of the type true, false, null, which represents a absence of data, and NA, which represents missing data. Alright, so let's begin by creating our first vector. As I mentioned before, all the elements of the vector need to be of the same type. So let's create a vector called subject name. And we're going to be concatenating the characters John Doe, Jane Doe, and Steve Graves. Alright, let's run that. Okay, so you can see in the environment tab that we have stored subject name, which is characters. If you want to prove to yourself that the elements of this vector are all characters, you can also use the type of function and put in subject underscore name and hit that, and it'll say right here in your console that it's a character. If you are wondering what a function does, you can hit a question mark and put type of, or any other function that you're curious about, and within this area of the help section, you get a description. Type of determines the type of or storage mode of any object. So that's what it does. Alright, so here I've created two more vectors. Temperature, which presumably houses the temperature of these three subjects in Fahrenheit and their flu status, either false or true. So these are going to be numerics and these are going to be logicals. Now, let's say I want the temperature of the second patient. So how do I do that? We can subset the data by putting temperature, square brackets, 2, and hitting enter. Okay, sorry, I didn't run this. There we go. And we get the value of 98.6 as we expect. We can also subset in a different way. So say we want the last two elements, so 2 and 3. We can use 2:3, and similarly, we'll get the subset of 98.6 and 101.4. Now, let's say we want the first and the third. What we can do is use temperature and we can use -2 and hit enter. And what this does is it removes the second element from the subset of the temperature vector. We can also subset in a different way. So for the sake of simplicity and understanding, let's create another vector called sub, and we'll concatenate the statement true, true, false. So what I want to do here is I want to get the first and the second elements of temperature, but not the third. Of course, you could use 1:2, but you can use this as well. And what you can do is temperature, square bracket, and you can actually use the word sub. One second. There we go. Let me run that, and you see we get the first and the third elements of that vector. Of course, you can do it directly as well. So you can use temperature without creating the sub, and use square brackets, concatenate true, true, and false. And this should give you the same result as the one above. And as you can see, they're equal. Alright, let's discuss factors. Now, if I wanted the gender of each subject, so John being male, Jane being female, and Steve being male, I could use strings. But factors are more efficient in terms of memory utilization, and I'll show you why. Just for reference, the semicolon gender is actually does the same thing as me putting gender on a separate line and actually executing that code. So let's run this. So what do we get in the output? We get male, female, male with the levels of female and male. So now you have levels when it comes to factors. And the reason it's more efficient in terms of memory utilization is you're not actually saving the full string. What you're doing by creating levels is you're saving an integer. So female has the value of 1 and male has a value of 2. Another interesting thing that you can do with factors is, let's look at the factor of blood. So John has a blood type of O, Jane AB, and Steve's A. We know that there's a blood type of B. So if you have that kind of knowledge in advance, you can create a level in advance that already has this B, even though it's not in your actual data set. Because if you later add to that data set, it would already be incorporated within the levels. So as you can see here, we have all the levels and the blood types of each person. So now let's say I wanted all of the info available for John Doe. What would I have to do? I'd have to subset subject name, 1, temperature, the first element, flu status, gender, blood, and that's a lot to type out in terms of like separate lines of code. It's not very efficient. So what we can use is lists. So what is a list? Well, a list is a special type of vector which can house elements of different types. So let's create a list for subject 1, which houses the full name, which is the subject's first name, temperature, flu status, gender, blood, etc. And let's run this. And what you get is all of the data straight away from just putting subject 1. Now if we wanted to subset the data, if we wanted the subject 1's temperature, so we can do subject 1, and we could use 2 because we know it's the second part of this list, second element of this list, and we can get the temperature. But also, what makes this particularly powerful is if you know the variable name that you're going to use, you can use the money sign and temperature. If you hit tab, you can basically autofill, and you get the same result as well. So similarly, the way we subset it above, we can create a subvector which concatenates temperature and flu status. And in a similar way, we can get the temperature and flu status of subject 1 directly by using subject 1, and we can use the new sub that we've created and hit enter, and what we get is the temperature and the flu status, which is false. Alright, so the next data structure and it's very useful as a data frame. And you can think of it, if you used Microsoft Excel before, as a spreadsheet. So there's rows and columns. So let's create a data frame called PT data using data.frame. We'll put subject name in it, temperature, the flu status, gender, blood, all of the things that we've created before, and we'll put strings as factors equals to false. The reason you want to do this is not all strings are necessarily ordered in the way that factors should be ordered. So like names are not going to be factors. Male and female might be, but names probably isn't. So just to be safe, you want to put strings as factors false unless you're very familiar with your data set. So let's run this. And what we see here, we can actually open up, I believe, PT data. And you can see basically a spreadsheet type format. You can organize this how you'd like. But yeah, we can go back into it. Now let's discuss some subsetting rules. So similarly to lists, we can use PT data, and let's say we want the subject name, and we get John Doe, Jane Doe, Steve. Wonderful. Now, what if we wanted, so we already have the sub up here, temperature and flu status. What if we wanted the temperature and flu status? So we can use the same thing. So since that sub's already created, we don't need to create it again, and use sub. And let's hit that, and there we go. We get temperatures and flu statuses for the 3 patients. Now, what about if I wanted the second? Well, it's the same thing as the second and the third. How about we abstract different rows and columns? So the way these subsetting rules work is if we use the square brackets, you have row, comma, column. So you can choose what you'd like to extract. So let's try this. PT data 1, comma 2. So what do we expect of it? We expect the first row of the second column, and that would be 98.1. And let's check if this is correct. First row, second column, 98.1. So yeah, that's what it is. And you can also concatenate data similarly. So we can use PT data. We can use square brackets. Let's concatenate 1, comma 3, comma. So that's first row, third column. Concatenate the second row and the fourth column. Yep. And what we get is the temperature and the gender for these people. Yep. So there we go. Alright, so now what if we wanted to get, let's say, a certain column or a certain row? So let's take PT data, and in a similar fashion, let's say we wanted to get the first column. You leave an empty space for the row and put 1 for the column. And that'll give us the subject names, which is the first column. Yep. And we can also get the first row, which should be all the data associated with the first patient. And if it's correct, yep, so we get John Doe, his temperature, his flu status, blood type, and gender. Okay. Okay, so there's various ways to subset data, and no particular way is better than another. So if you find yourself subsetting a set of data and you want a result and you get that result, as long as you're able to understand the logic yourself and explain that logic to someone else, it's fine. So here's 2 examples of this. We're going to create a subset that we're going to store into Q and a subset that we're going to store into R from PT data. The result of Q is the first and third rows and the columns of temperature and gender, and that's also with R. And we can see that these are all equal as well, not just by their output, but we can put all equal, actually we're going to use all equal character here, and Q, comma R, and we hit enter. And as you can see, that's true. So you can confirm that the output is actually the same. And by doing so, you can prove your logic if someone's questioning it. All right, let's look at matrices and arrays. So we're going to create two matrices here, which are data structures that house a single element within their columns and their rows. Typically, these are numeric, so you can do mathematical operations here. But here we're going to use characters. So we're going to create a matrix by concatenating A, B, C, D, and we're going to have two rows. So since there's 4 elements divided by 2, you're going to have 2 rows and 2 columns. And we can confirm this by showing C. You can see 2 rows and 2 columns. With n, I think you can figure out n columns is equal to 2, but we still have the same number of elements. So this also should have 4. And what we get is the result. Now we can check if m and n are equal by doing all.equal and writing m, comma, n. Sorry, comma n. Let's hit enter. So that's true, and basically what that means is these are equivalent matrices. So the ordering of matrices is done column-wise, and the best way to illustrate this is through an example. So let's assign M the matrix A, B, C, D, E, F with 2 rows. Now we have 6, so we should expect 3 columns, and that's what we get. So let's actually look at this data. So what happens is the columns are filled in first. So A, B, then since we only have 2 rows, it goes to C, D, and E, F. So now let's look at the other matrix where we have 2 columns. Similarly, we should have 3 rows, and now this output is actually going to be different. Alright, so now let's see how subsetting works. What we can do is we can extract similarly, we can extract the first column, or sorry, the first row, or we can extract the first column if you want, and likewise you get the results that you would expect. So let's write a CSV file. Write.csv, and we'll use this later. We'll read the CSV in the second part of this chapter when we're doing some data analysis and explaining how to read data, interpret data, understand some basic statistics, and how to interpret and graph things. Alright, so let's see if this works. Perfect, and we've written the CSV file. One thing to note that wasn't mentioned in this chapter with matrices, say you had numerics in here and you're multiplying 2 matrices together, it'll actually multiply the elements of each matrice and not do a matrix multiplication. So the first element of the first row, first column will be multiplied by first row, second column, and you'll get a resulting n by n matrix. So it'll be the same. It wouldn't be a matrix multiplication if you guys are familiar with that from linear algebra. But yeah, that's pretty much it. Arrays are just multi-dimensional matrices, so you can think of them as sheets in a spreadsheet or layers of rows and columns on top of each other, and this can be an n-dimensional system, but it might not necessarily be needed for the purposes that you want to use machine learning for. So we're going to move on to part 2 now.